Unit 10, Worksheet 3, Coulomb's Law. So problem 2. How much does the electric force between a pair of charged bodies diminish when their separation is doubled and then tripled? So we're going to separate this up into 3 parts. The first part is we're going to write down our way to quantify the electric force. We're going to use Coulomb's law to do that. So our electric force is equal to the charge of one object times the charge of a second object times Coulomb's constant, Ke. All of that's divided by the distance between them squared. Now, for this problem, we're asking to see how this value would change if we went from 1R to 2R. So we double the amount of R we have. So if we now double the R, then our new electric force will be Q1 times Q2 times Ke. That hasn't changed, but now we have 2R, and then all of that gets squared. So what that would be is we'd still have the same numerator, Q1 times Q2 times Coulomb's constant, divided by 4R squared. Well, our initial force is determined with charge 1 times charge 2 times the constant over R squared. Now we have that same thing, charge 1 times charge 2 times our constant divided by the radius squared. But now we also have a 4 on the denominator. So we could write that as 1/4 of our electric force. So when we double the radius, the electric force is diminished by 1/4. It is now a fourth as strong as it once was. If we were to do the same thing when we triple the radius, then we would have that same numerator. And our denominator, we now have 3R instead of just 1R. We square that, we get same numerator, but now it's 9R squared on the denominator. So we end up with the exact same thing for our Fe, but now it's 1/9. So when we increase the distance between objects, we're reducing the amount of electrostatic force that we have. If we double the distance, we 1/4 the force. If we triple the distance, we 1/9 the force.